Thank you for coming. We are the security and AI group, and this summer we focused on user authentication. I'm Jacob.
Hello, I'm Damon.
I'm Ethan.
And my name is Root. Our advisor is Professor Chen, and our mentors are Tianfeng Zhang, Changmin Li, and Honglu Li. Okay, so the overview behind our project this summer was to create a mobile sensing system using Wi-Fi and mobile devices and to test them under adversarial attack scenarios. So we utilized mobile devices or IoT devices to extract channel state information data from the Wi-Fi packets that it sends and receives either from between the device and a router or the device and another device. And we use this data to generate user authentication and human activity recognition models. So basically using that data, the model can recognize if your activity, so if you're walking or kicking, or who you are.
So this is the motivation behind what we were doing. So firstly, we wanted to implement a new Wi-Fi sensing technique, which uses a learning-based approach for accurate and efficient recognition tasks. So basically, like what we were saying before, it should be able to recognize the activity you're doing and authenticate your user. Secondly, this can be applied to various devices. So your cell phone you have, a laptop you have, or even a tablet, or even Wi-Fi routers, which we'll talk about later. And the best thing about this is that it actually has passive engagement from the user. So the difference between a passive engagement and active engagement is that active engagement actually requires you to put your fingerprint on the phone or put your phone up to your face for facial recognition. However, with our Wi-Fi sensing techniques, you can just be simply walking, basically doing things that are passive and don't require you to do anything. And the motivation behind this one is biometric hardware, such as Face ID and facial recognition. A lot of those can be hacked, and a lot of those have a lot of security flaws, and our Wi-Fi use sensing techniques basically cannot be replicated from person to person. Secondly, so our learn-based techniques, so in this case deep learning, they're vulnerable against adversarial attacks. So this means that the input data can be manipulated and the model can be fooled by the attacker. And the motivation behind this is because deep learning models are vulnerable against adversarial attacks that fool the model into false recognition scenarios using obfuscated data. The only way to obfuscate this certain data is to jam all the signals in the IoT authentication scenario. And lastly, so research and adversarial attacks against Wi-Fi sensing systems, they can create a lot of security concerns. So the input data can be manipulated or the user can be blocked from his or her property, which is obviously not a great thing. And the motivation behind this one is, again, if we can attack our own model, we can actually increase the robustness of our model, increase the accuracy.
Okay, so I mentioned IoT devices before. What are they? Anything that can be connected to the internet is an IoT device. So it can be any of these up here. It can be your laptop, your phone, even your Apple Watch. Essentially, all of these all of these devices are able to receive Wi-Fi packets, and they're also able to transmit them. And using this, between two devices, there's a channel created, kind of like a tunnel, where any interference between that is also picked up. And that's kind of the motivation behind how our system works. We can perform different behavioral movements for each person, and that will be unique to every single person. So how Ethan walks is going to be different from how I walk. And that interference, the change in how that interference occurs in the Wi-Fi packets will be picked up by the model.
All right, so a quick introduction into what our project started with is we can extract these CSI information, the Wi-Fi amplitudes, and pass them through deep learning models, which extract features, and they can learn, it can start to differentiate different activities, such as like walking and comparing it to squatting or other activities. And it can also help us differentiate the user performing the activity. So that's why we're using deep learning models.
All right, so moving on to actually setting up the experiments, we received sort of a manual from our mentors on how to do this. And so the first step on that manual was to actually set up a virtual machine on VirtualBox, and this ran Linux. Linux is an OS, and it was much more compatible with this firmware or what we were trying to do. And the firmware we were trying to install is called Nexmon, which is just something that interacts with the Wi-Fi chip inside your phone or your device and extracts information out of it. And this firmware was made by the guys at Simu Lab, and we just cloned their GitHub code onto the VirtualBox. And this firmware was strictly compatible with a couple of Nexus phones in our case. So we used 2 Nexus 5s and configured one as a receiver and configured the other as a transmitter. And then afterwards, we set up the experiment, as you can see in the bottom right, and to try and collect CSI data.
So you can see the videos on the left and right. They're going to play soon. So basically, this is Ruud and Jacob performing the kick activity, and you can see the transmitter on the front and then the receiver on the right. So the transmitter would output CSI Wi-Fi packets, and the receiver would take them in, and they would be stored into a computer, which would then be put into the deep learning model to then train on itself.
We were able to collect measurements for kicking and squatting activity that we're showing. If we look at the squatting activity, each spike in the graph represents a squat, and we performed multiple squats to collect the data. And what we came to the conclusion was we were able to authenticate users 96% of the time. So if I was doing a squat, the model would correctly predict that I was the one performing the squat 96% of the time, which is very, very high accuracy. At the same time, someone with access to our model and data, an attacker, could trick the system into thinking that if I was performing the squat, it was actually root. And this is why security in AI is so important, because we want to be sure whoever is performing the activity is really who they are. And but in reality, an attacker might not have access to the data or the model. So an actual attacker might not be able to hit 80% success rate in tricking the system and bypassing like authentication.
And that's it. Thank you. Any questions?